The scenario we are looking at is the largest quarry in Europe for limestone extraction. We are in Belgium, in the Guérin quarry of the Italcementi group, and our project represents an intervention on two lines, respectively called Stockpile and remontèe carriere. The intervention area is in the Valloni region near the town of Tournai, close to the Atlantic coast of the North Sea at an altitude of 37 IGN, in an area that is not affected by earthquakes. The temperature is between -15 and 40 degrees centigrades. Ciment Calcia, designated by the parent company of Italcementi, in December 2009 invested SAMI with the planning and manufacturing of two limestone transport lines, with works completion at the beginning of 2011. The first line, called Stockpile, concerned discharging material from the existing line of the Milieu site up to the new limestone stockpiling. The second line, called remontèe carriere, was for the transportation of stocked stone to the secondary crushing plant up the quarry slope. Several parts of the already existing plant were recuperated and modified, i.e. TB5-TB6 conveyor, the car 32-33 angular tower and the car 33 conveyor belt overlooking the cement tower. The first activity to be carried out was the on-site data and information collection that represented the necessary input to pass on to the planning office for the reorganization of the plans to be made. This was one of the most important phases and consented the individuation and development of the layout for the reorganization and dynamic loads for statistics analysis. Everything was under the scrutiny of local organizations. A team of engineers, technicians and designers from SAMI paid special attention to the drafting of the executive technical layout of each single part of the plans to be manufactured. The reports supply the workshop teams with the necessary information regarding the list of materials, dimensions, bolts and nuts list and accessories. (1,600 tons of components were made in 6 months, comprising around 1,100 tons of general carpentry, about 250 tons of various mechanical carpentry, and about 250 tons of various commercial components. To summarize the most important: rolled HLB 1000 profile beams at the base of the stockpile, transmission heads, idle heads, counterweight grips, discharging conveyors, rollers, belts, gangways, metallic bridges, pilasters, plugging and coverings, bypasses, pipe fittings. All components were made with quality material and some covered with a 20 mm anti-abrasion plate. The location of the intervention site was immediately problematic due to the difficulty of access, and it was necessary to make secondary roads for motor vehicles. Special attention was paid to the coordination of the various work teams dedicated to the various work phases, striving to avoid fastidious overlapping by means of precise activity planning. Enormous earth-moving and building works were carried out. Bearing witness to this are the reinforced cement works made for the stockpiling area, which are an emblematic example of the greatness of this work. Huge caterpillars and towering cranes were employed in the transport and assembly stages, without which it would have proved impossible to handle the artifacts for final assembly. Sami carried out a whole series of pre-assembly and testing in its own workshop in order to guarantee effective correspondence between the designed and manufactured parts. Engineers, together with workshop technicians, verified the main components, pre-assembling the parts of the plant for all technical function analysis. Especially spectacular was the workshop testing of the TB8 conveyor tripper with a capacity of 2,500 tons per hour, with a width of 1,400 mm and axle base of approximately 116.4 meters in a horizontal position. Various transport was necessary due to the size of the work, including 2 exceptional trackages from Italy to Belgium. The transport convoy was 24 meters long. The transport system was planned specifically for the transport of limestone. The 0-200-250 mm stones from the new G3 crusher or the existing G2 one will be sent both to the new TB7 conveyor by means of a new channel complete with a deviator and installed at a TB5 discharge, and to the TB6 conveyor in use in order to assure crushed stone stockpiling. This new TB7 will arrive in an angular tower and will discharge the stones onto the TB8 conveyor, installed downstream, complete with a tripper to discharge the stones 0-200-250 mm in a stockpile with a capacity of approximately 50,000 tons. The stones are then measured and transported by means of a series of new batching plants and extraction conveyors towards the remontèe carriere line. The TB7 conveyor has a capacity of 2,500 tons per hour, belt length 1,400 mm, interaxle of approximately 108.4 meters and inclination of approximately 2.7 degrees. Installed in a covered and plugged metallic tunnel, complete with a 600 mm gangway and the other of 800 mm with only one central pilaster, approximately 24 meters high and formed by 2 spans of about 45 meters each. TB7 TB8 angular tower, amply sized and braced, about 8 per 8 meters per 29 meters high, with 3 covered and plugged levels, complete with floors for equipment, beams for maintenance with hoists, and with the necessary accesses for the maintenance of the different plants, and a ground access ladder allowing the passage from the ground to the higher floor. A gangway will link the angular tower and the ground near the cabin of the S1 crusher. The TB8 conveyor has a capacity of 2,500 tons per hour, complete with tripper belt, length of belt 1,400 mm, interaxle of approximately 116.4 meters horizontal, installed in a covered and plugged tunnel with 800 mm gangways on both sides. The tripper, for the course of approximately 90 meters, will have a winding drum for power cables and another for command control, a guidance system on motorized wheels, and a double discharge channel. Large braced covered stockpiling warehouse measuring 48 par 80 meters per 27 meters high. There will be 800 mm gangways on each side of the conveyor for the tripper conveyor service. There will also be a platform for control equipment with a gangway about 10 meters in length outside the structure, leading to a series of ladders with intermediate landings for evacuation in case of emergency. The remontèe carriere line includes two new conveyors, the T-car 54 and T-car 55, the modification and extension of the existing car 32-33 angular tower, the extension of the existing car 33 conveyor up to the new secondary crushing tower for cement. A 750 tons per hour T-car 54 conveyor with a 1,200 mm wide belt, an interaxle of approximately 195 meters in horizontal with a 14-degree inclination in a tunnel with two gangways, one 600 mm and the other 800 mm. It will have four palisades ranging from 6 to 24 meters in height for support. Modifications and bracing of the existing 32-33 angular tower to allow for the arrival of a new T-car 54 conveyor at a height of plus 26.05 above the existing car 32. Expansion and raising of the tower for the transport of the new conveyor at a height of plus 17.45 towards the new secondary crushing tower in the plant. A 750 tons per hour T-car 55 conveyor with a 1,200 mm wide belt, an interaxle of approximately 182 meters in horizontal with an 18-degree inclination. The tunnels of the roads crossing the cement factory will be completely closed. The lengthening by approximately 18 meters of the existing car 33 conveyor with a supply of necessary equipment such as beams, foot support, upper sheeting, lower drums, control drum with magnetic lamp base, magnetic steel casing of the magnetic steel control group, and the movement and modifications of the existing control group. In conclusion, it can be said that with this project, SAMI has won another challenge from a productive and technological point of view. The technical solutions and innovations carried out launch and consolidate the company on the global market, which today is even more difficult and competitive.